The problem is like this. This is a system you are seeing. This is of 2 kg, 2 kg. The angle of inclination is 30 degree, and this is a block of mass m. There is no friction. The surfaces are smooth. Now you have to find this mass m. How much mass is of this block? So this is also a simple problem, but you should try your hand on this. So where do you start from? We'll start from here. Finding tension in this string is straightforward. T will be equal to mg. So T will be equal to 20 Newton. This is the same rope. There is no knot. There is no hindrance. Tension here will also be 20 Newton. Let's draw the FBD for this 2 kg. 2 kg block is kept like this. The tension, this is 20 Newton. This is mg. Mg is also 20 Newton. There's a normal reaction, N, and there's a tension on the other side. This is a different string, the tension won't be the same. So we have to find this T. Once we find that T, then T again here will be equal, this is T dash. Suppose if we find T dash, then T dash will be equal to mg. We'll find m from there. So the task is to find T dash. And to find T dash, let's find all the forces in the line parallel to the plane. Because normal reaction is perpendicular to the plane, T dash is parallel to the plane. So we'll be looking at the forces, or we will looking for the equation of static equilibrium in this line parallel to the plane. In that case, normal reaction will not be required to deal with. So writing all the forces parallel to the plane, this angle is 30 degree. Okay, so the forces in the downward direction of the plane is 20 plus 20 sine 30, and the force up the plane is T dash. These two must be equal. So T dash comes from here as 30 Newton. Normal reaction, if they ask, you can tell that normal reaction would be equal to, if you see the force in this line, N will be equal to 20 cos 30 degree. So that would be 10 root 3. But that is not required here. T dash is 30 Newton. If you see and draw the FBD of this mass, mg will be equal to T dash. So T dash equal to 30 Newton will be equal to mg, m into 10. So mass from here comes as 3 kg. Okay. So you have to break the forces into components and find the variables. Okay. So if we ask, or if somebody asks, how much force is this string exerting on this pulley? So can you find the force that the string is exerting on this pulley? If you draw the FBD of the pulley, there will be some tension, T dash and T dash in these direction. The angle, this angle would be how much? The angle would be 60 degree. This is 30, 90, this would be 60. So this is 60 degree, and the tension, you know, there are two vectors. Tension we calculated as 30. So there are two vectors, 30, 30. The angle between them is 60 degree. Long back, do you remember we learned the addition of vectors? So you can add these two vectors. You know, well, you very well know the formula of addition of vector. You know the values of the vector. You know the angle. So there's nothing that can stop you from finding the resultant vector, which will come out as 30 root 3. So 30 root 3 is the total force that the tension is that the string is exerting on the pulley. So 30 root 3 force will be acting in this direction. So this contact must also apply a force of 30 root 3 on the other side for the pulley to remain stationary. But nevertheless, the force that the string is applying on the pulley is 30 root 3. Okay, so now we had enough practice of these kind of problem when we were dealing with situations where the system as a whole was stationary and nothing was moving. So as per the Newton's first law, what we did is Newton's first law said that the system will preserve its state of motion. That means it will remain at rest if it is at rest, and it will be moving with uniform velocity in a straight line if it is doing so, unless there is some net external force. So we use that concept. System was stationary, so we went backward in the definition. That means that there is no net external force, and we drew the FBD and we made the net external force in vertical direction and horizontal direction, parallel to the plane, perpendicular to the plane, is equal to 0. So that's how we were able to find some of the variables when we were given some of the variables. So that's what we did. Now what we will do is we will take a major leap forward and we will move on to the Newton's second law, which will deal with situation in which the systems are moving. Newton's first law says that the system will remain at rest when there is no net external force. But if there is some net external force, then what will happen? So the answer to that comes from the Newton's second law. So what we will do now is we'll move on to Newton's second law and study situation where things will be moving.